Hello, I'm Bob Duffy, Intel Developer Program Manager and Blender user. In this video, I'm going to show you a little bit about the Intel Open Image Denoise, talk about how to use it in Blender so that CG artists, game developers, media developers can make use of this technology to speed up ray tracing and get quality results.
Before we get started, let's discuss denoising, what it is, how it speeds up the time of ray tracing, and how the Intel Open Image Denoise uses advanced methods to increase the speed and quality of denoising. Most modern 3D rendering engines use a form of ray tracing called path tracing to create beautifully realistic renders. Path tracing works by mimicking light, shooting virtual light rays from each pixel location in an image to objects in a virtual scene. If an object is translucent, then the ray will pass and bend through the object to objects behind it. Information on light, shadow, color, and surface properties of each virtual object bounced along the path defines the color and luminance of the pixel. Each light ray per pixel is called a sample. The more samples you have per pixel, the cleaner a render is, but longer it takes to render. The fewer sample rays per pixel, the grainier or noisier a render looks, but the faster the rendering is done. To get a pristine render, it may take thousands of samples per pixel and even take hours per frame to generate. Denoising is a computer algorithm that cleans up the noise when using a lower sample per pixel count. This can create beautifully clean renders in a fraction of the time. To date, many denoisers did a fair job, but in areas of low light or textures, denoisers often create unwelcome patterns in a final render. The Intel Open Image Denoise library, part of the Intel oneAPI Rendering Toolkit, uses artificial intelligence to more intelligently denoise a render, and the results can be stunning. The Intel Open Image Denoise library is now part of Blender 2.81. You can go to blender.org and download the latest release of 2.81 or greater to make use of this open source library from Intel. This feature will improve renders for film, game cutscenes, or game textures using fewer samples, saving digital artists and developers a lot of time. Welcome to this demo and tutorial of using Intel Open Image Denoise in Blender. For this demo, I am using Blender version 2.82. I'm using that version to demonstrate the improved rendering using the albedo rendering layer. I will demonstrate that later in this demo. You're going to want to open up Blender and have a scene that you create or that you've imported in using the Cycles rendering engine. I suggest that a scene be used that has shadowed areas that isn't perfectly well lit. That's going to give you a better idea of the noise because noisy areas are best shown in areas of shadow or there's just not enough light. To demonstrate this on an actual render, I'm going to take my rendering samples all the way down to 32 samples. You usually would do a render of hundreds or thousands of samples in order to do a clean render. So this seems counterintuitive. Why are we going in the opposite direction? One is to demonstrate this on video and also just really demonstrate how fast of a render you can create that will look clean with Open Image Denoise. So with that done, move over to the compositing tab. This is where the denoise happens. It doesn't happen in render, it happens after the render is done. To make use of it, make sure that nodes is selected and you'll want to make sure that your render layer and your composite node are connected by image. Then over in your properties panel, in your layer properties, find denoising data and turn that on. So make sure that that is checked. You will see that you'll have more information available to your render layers. This is important information to do denoise. Then go to the Add Node, search for Denoise, select it, and this is the Intel Open Image Denoise in node form. To get this to work, it's as simple as connecting it. You connect the output of the image render to the image input, same with the denoising normal, and same with the albedo. These layers are used to improve performance and also to improve the quality of denoise. I'm not going to, usually you would connect this last little bit, but I'm going to do that after the render so that you can actually see it happening in work. So I have my rendering scene. I'm going to make sure I can see a lot of different noisy areas. So areas of low light, like the back of this box here, where these caustics are, I expect those to render very noisy. So I'm going to go ahead and F12 to render out, and then switch back over to compositing where I can view this. And this is completing its render. So this is exactly the noisy areas that we're going to see cleaned up by the denoiser. This kind of stuff is going to get cleaned up. So that took 15 seconds to complete. It's a short render because we have low samples per pixel. So the last part to do is to go ahead and connect it. I'm going to make sure that you can see an area of noise as I connect it. So I will connect it here, let go, and there it is. That area of caustics is all cleaned up. And let's look around the image so you can see that area here where it was all noisy, all perfectly clean. And that's all you need to do. That you just need to connect the nodes, make sure that denoising data is on and it's working. As you do another render, this will work for you. So every frame that you render, or as you move your camera around and create another area of rendering, this will all work. I'll go ahead and render this frame just to show you that this is going to render noisy, but once the rendering is done, compositing will take effect with the node, and all this noisy area will get cleaned up. And it's about done, and there it is. So that's all cleaned. I also want to show you how well it works with the albedo plugged in here. So I'm going to disconnect this and then focus in on this Intel logo here. So as we zoom in, you know, it's a little bit muddy, artifacty, pixelated. Let me reconnect the albedo. We'll look at the Intel logo and see what happens. There it is. It's much cleaner. It's much crisper. And you'll notice across area here is like the Intel box. That's super clean. But area where we have normal information, like the stack of cards, that normal information is preserved. The clean lines of the Intel logo, all preserved. All the text area is well preserved. We didn't, with the denoising, muddy those up or create any unwanted artifacts. It's perfect and it's pristine. That's all there is to it. I would suggest playing around with it. A couple of things you might want to do is reduce the number of samples. Find out how low can you get the samples. You know, how quick can you get a render, but still have it look good with denoising. Another thing you might want to do is play with the lighting. Dim the light down. I mean, how dark can it get? You know, how little information of light can be available before you kind of can't. Denoising really doesn't do anything. It doesn't make an effect. And the other thing to really play around with is the compositing itself. Because it's done in the compositing layer, you have access to all sorts of other things. You could add in, I don't know, something like a color ramp here. So you could add a color ramp in between these image areas here, where let's just say that the areas of darkness, you want to make sure that that's denoised, but not the areas of light. And so you can mix up your denoising so you denoise certain areas, but not everything. It's up to you. You're the artist, you're crafting this, and you have all the flexibility that you want to apply denoising how you want to apply it, thanks to nodes and using it in the compositing area. So that's it. That's all there is to the Intel Open Image Denoise in Blender. To learn more about Blender 2.81, the Intel Open Image Denoise, and other parts of the Intel oneAPI Rendering Toolkit, follow the links below.